I would like to speak about some special characteristic of the ECG and respiration. Already this morning, some other colleagues spoke about link between respiration and ECG. And looking at this bad slide, you can see that this strip refers to the ECG. Let me see. So the top strip refers to the ECG, very compact representation of the ECG, and the next one refers to the respiration. And you see that on the ECG we have a modulation of the amplitude of the ECG. And not only a modulation, but we see that also the frequency change and according to the inspiration and expiration phase of the respiration. So there exists a relationship between the electrocardiogram and respiration. This modulation that is visible on the ECG trace is evident also if we do the spectral analysis of the heart rate time series. For instance, everybody knows that using the spectral value, spectral envelope of the heart rate, we have two main peaks, one at low level and another one at high level, that is named HF in this slide. And the peak or the power of this peak is strictly related to the amplitude of the respiration, and this power is mediated by the activity of the autonomic nervous system. So there is this modulation of the respiration on the heart rate. In this presentation, I would like to speak about something different. I would speak about the specific characteristic of the ECG and respiration that is named synchronization, or better, phase synchronization. What I would like to say is that speaking about synchronization, I am speaking about the computing of the delay between the single cycle of the ECG respect an event that in this case is the beginning of the respiration on modulation, the respiration trace. In this case you see that from this ECG cycle and the beginning of the respiration, there is a sort of delay. There is a delay that is this segment blue. From the second beat of the ECG, there is another delay from the beginning and the second beat, and so on. So, if this relationship is constant, this delay are constant, I say that there is a phase synchronization between respiration and ECG. In which way I can compute this relationship between ECG and respiration? No, there are many methods. One of these methods is named the synchrograph, and it's done in this way. Let me consider a respiratory trace like this one, and an ECG trace in which this moment in these pictures is represented by this arrow that corresponding to, let me say, the R wave of the ECG. So taking an interval on the slow wave that is the respiration, in this case I take 2 waves of respiration. In this interval I search for the time at which each arrow, that means each ECG cycle, how is this ECG cycle is related in phase respect the beginning of our interval. So this point that is corresponding to the first ECG reference inside the interval of respiration, I have this point. The second cycle has this delay respect the respiration cycles, and so on. So I compute the delay at which occur each event of the ECG, in this case the R wave, respect to the beginning of the respiration waves. In this case, as I say here, I consider an interval that is 2 respiration waves long. If I trace this point that is obtained in this way in an X-way representation, like here, I have a problem in moving the mouse here. In the X-axis I have the time, and the Y I have this point, this dot that I computed in that way. I obtained a sort of representation, and if I consider the horizontal line, this horizontal line represents the phase moving along the time of the ECG respect to the respiration. If there is a stable relationship, a constant relationship in phase between the ECG and the respiration, I have a line, an horizontal line. So any horizontal lines means that there is a stable relationship between the ECG and the respiration. That means that we obtain a phase lock of ECG between ECG and respiration. This is an example of the application of this method that is named synchrogram. The first 2 strips are related to the respiration and the ECG. And the third one is the synchrogram representation. The first 2 has a different time scale. 20 seconds for the first 2 and 5 minutes for the second one. And you see that here you see that you have some stable line, quite horizontal. And in this interval, we have synchronization, phase synchronization. That means that there is a stable phase between respiration and ECG. And here, the interval is quite long. I have other periods in which the phase is stable, but are shorter. Anyway, this synchronization is quite rare in the normal life. During daily life, it's quite rare to find this phase synchronization between ECG and the respiration. But in some situations, this synchronization appears and continues sometimes for many minutes. The presence of synchronization is sometimes not considered because somebody, mainly at the beginning of the 2000 or at the end of the 1990s, researchers considered the presence of synchronization the effect of some random phenomenon, so it was not real. In this paper that was of the 2002, very nice, from Toledo and Axelrod, they applied synchronization to different patients or different subject, normal subject, and from the patient they consider some transplanted patients. And they used also some surrogate data like you see the last picture that is at the top, at the bottom of the figures. In this surrogate data were used, come from the data coming from one patient. For instance, the heart rate from the ECG from one patient and the respiration obtained from another patient. Just in this case, it's impossible to have a synchronization. And they used this data just to avoid to test if, in this case, synchronization occur or not. At the end of the paper, after the test, they conclude that synchronization is a real phenomenon. And applying synchronization to different kinds of subjects, for instance, to the transplanted patient in which the heart or the heart rate was completely disconnected to any condition coming from physiological controlled system. So they found in their experiment something very strange. So they found that for transplanted patients, the synchronization was higher than in normal subjects. And that is what very, very, very strange. And at the end of the paper, they suggest something about this finding related to the transplanted patient. For instance, they consider that this increase, this enhancement of synchronization could be due to a mechanical coupling between the heart and the respiration system, not hidden by fast neural control mechanism as in normal subject that promote synchronization. Or another cause of the increase of synchronization in transplanted patients was due to that respiration is adapt the frequency to the rhythm of the HR for the heart to the heart rate. For what concerns the meaning of the synchronization, always say in this paper, they say that it can be a consequence of a mere coupling between a non-linear system. That means that the synchronization has no special meaning. It happens, but without any special meaning. So such synchronization, being a secondary mechanism, does not necessarily bear physiological advantage. Or, another possibility, they say, that synchronization has an energetic benefit, since the reduction in intrathoracic pressure increases cardiac filling and thus thoracic output. Therefore, synchronizing heart rate and respiration may increase cardiac output while conserving energy. So they found that the synchronization is a real phenomenon, and they found also that is associated to different clinical, different pathologies or health status of patients. If this is true, it's possible to classify, for instance, using synchronization, different kind of patient. In these other papers of the 2010, synchronization was applied to classify for the classification of post-infarction patients. And they found that the reduction of phase synchronization was correlated to high mortality risk index. Sorry. So the synchronization can be used for characterize the patients. Now we have some rest, and I would like to play some song. I'm not crazy, but if I would like to play some song, because it's interesting, it's important to understand some better what is the synchronization and when appear synchronization. Om mani padme hum, Om mani padme hum, Om mani padme hum. Okay, this sound that is a mantra, no? Is a mantra, and is if you hear the sound, you see that there is a rhythm under the sound. So, and if you compute the rhythm of this sound, you see that this rhythm is constant, so there are phrases repeated many times, and is more or less 10 seconds. Consider that this chanting is oriented to promote thinking and meditation, is for relaxing. So, the origin is in the Eastern countries, in the Buddhist religion. This kind of chanting oriented to relax people and to have good meditation, good thinking, is present not only in Oriental religion, but also in Catholic Church. In Rosario, for instance.
E benedetto è il frutto del tuo seno, Gesù.
Santa Maria, Madre di Dio, prega per noi peccatori, adesso e nell'ora della nostra morte. Amen.
Ave.
So anyway, everybody knows that, or remember that when we were a child, we hear many times this prayer that is a rosario. And if you count the time of this, follow these different periods of speaking, of chanting, you see that also in this case, the distance, the period is about 10 seconds. What is important is that all of these procedures, that is a religious procedure, bring to a feeling of well-being, of wellness. Chanting, relaxing, at the end we feel better. That is important. What if I look at the characteristic of this chanting, we see that the breathing decreases in frequency. For instance, here you see the spontaneous breathing. Of course, on the x-axis, on the x-axis you have the time, and you see that you have the frequency is very high. During the mantra or Ave Maria or Rosario chanting, you see that the frequency decreases a lot and goes around at 10 second period. And this happens not only for the breathing, but also for the heart rate. The component of the breathing, of course, move to the heart rate time series. Here is evident that is present on the heart rate the same oscillation at low frequency. And the same happens also for the blood pressure and so on. If I consider the power spectrum, in which it's possible to see exactly at which frequency is the respiration, we see that this frequency coming from spontaneous breathing to free talking and to recitation. Recitation means recitation of rosario or mantra. We see that the frequency decrease from spontaneous breathing to, and we obtain the value, the peak at lower value that is close to 0.1 Hertz. This effect of moving the frequency, the respiration frequency, from high value to low value is obtained also with other techniques, like during poetry recitation. In this paper of the 2004, that is named Oscillation of the Heart Rate and Respiration Synchronized during Poetry Recitation, we obtain exactly this effect. During poetry recitation of hexameter, hexameter is a sort of recitation of verses that are this recitation is rhythmic. In this case, the recitation refers to some verse like those present in Iliad and Odyssey of Homer. So hexameter is a sort of verses that are used in the ancient Greek many, many years ago. So if you have, during this kind of recitation, of a poetry recitation, in this case too, you obtain an increase of the synchronization due to the decrease of the respiration frequency. And it's clear in this tool to panel. You see that in the bottom panel, in the small one, you see this peak that refers to the phase that is present, that is stable, and there is a peak very high. That means that there is a synchronization. It's a very good synchronization. There is a synchronization, phase synchronization, very stable. In the other panel, in the upper panel, this one, this refers to free talking and free breathing, and where there is no synchronization, there is no peak. The phi, that means the phase, is does not show any peak. So, just at the end of this very short review of synchronization, we can do some comments. All the theta practice brings to a low respiration rhythm. That is very important. And this timing is closer to the endogenous circulatory rhythm, that is about 0.1 Hertz, 10-second length. In all of these practices, there is an increase of cardiorespiratory phase synchronization. So all of these practices do an increase of synchronization. And we remind that all this practice gives a general feeling of wellness and well-being. The physiological origin of synchronization at the moment is not known. Is not clear. Of course, there is an involvement of the central autonomic nervous system, but in which way they play a role in the occurrence of the synchronization at the moment is not clear. Anyway, synchronization is associated to a feeling of well-being. So is associated to the health status. So probably in the future we can use the synchronization as an index of the health status of a patient or a subject, or an index of the good trend of rehabilitation. Thank you for your attention.
Thank you, Alberto, for this very nice presentation. Are there any questions in the audience? Yeah, Catherine?
Thank you very much, Alberto. It was a great presentation. My question is, how does this relate to the work that was presented by Georg this morning? He spoke about some indices, and he also said that the first.
No, this is a different, okay, because George this morning spoke about modulation of the heart rate due to the respiration. And he spoke about a sort of synchronization, but the synchronization was not exactly this kind of synchronization. This is a phase synchronization that is a bit different. So this is searching in which the constants of the phase along the respiratory rhythm. That is some specific features that it was not considered, or anyway is not so evidenced in the presentation of this morning. This is a feature a bit different. That was included probably in what George said this morning, but this is enhanced, is more evidenced.
My understanding was that the failure to synchronize
Yes.
indicates the presence of pathology, or that's how
No,
I
no, no,
interpret
no,
it?
no, no. It's not because normally during the daily, I told before, in the daily life, the synchronization is a condition that doesn't happen. So normally when I speak, when I run, everything, there is no synchronization between heart rate and respiration. Just in some specific condition you can. The papers that I showed during this presentation, they refer to data collected in some specific condition that during resting or during sitting, but in the very special cases, or during recitation of something, and so on. So, but normally it's quite rare to find synchronization.
We have time for a very short question. Philip, you have one of this?
So it's homemade software you have, no?
No, yes, of course, but the synchronogram is a software available on the web, so you can use it.
We can use it?
Yeah, no problem. It's quite easy. There are other methods quite complicated because there are different methods. The last one, this kind of method is a bit different from synchrogram. No, but all of these methods are available on the web, free.
Is there any correlation with the brainstem activity? You know, there is
You can use your hand. There are some papers that takes the yes. You can right. You can consider the activity of the you use a channel or EEG channel, and you compare the activity of EEG channel, the cortex activity with the synchronization. They found, for instance, that the decrease the cortex activity decrease the synchronization because the mental activity are contrary to the presence of synchronization.
and for you it's close to the vagal activity?
I don't know. Sorry.
There's no correlation of...
I don't know.
Okay.
Thank you.